This video is for those students that have missed Unit 4, Class 3 due to a whole variety of reasons. In this class, we're going to look at a technique we can use for solving systems of equations. Now, before we start, I want you to pause me and in your math journal, solve this system by graphing. All right, pause me and come back after you've graphed. All right, welcome back. I hope you had a little bit of a trouble when you graph this. Here I'm going to show you a picture of the graph from Desmos. Here's the system. And here's our solution. Here's our point of intersection. Now, what's wrong or what's hard about this? Well, notice we can't really accurately read the coordinates for our x and y value. We know x is probably going to be something less than a half, and y is going to be something between 1/2 and 1, but we can't read that any further. Now, as mathematicians, are we stuck? Of course not. We have other techniques that we can use to solve systems. So we have two algebraic techniques. One is called substitution, and the other is called elimination. Now, both of these techniques work on the premise that we're starting with a system with two equations and two unknowns that we can't solve. So we want to turn it into something that we can solve, which is one equation with one unknown, one variable. And both of these algebraic techniques use this sort of overarching strategy. All right, so let's go back and we're going to solve this system now using one of these algebraic techniques that we call substitution. Here's the way it works. So with substitution, we can take anything that a variable equals. It might be a number. It might be an expression, and we can substitute it in for that variable. So here with this system, notice our variable y is equal to this expression 4x minus 1/6. So we can take this expression and substitute it anywhere the variable is y is. And remember, for a system of equations, the variables mean the same thing. So I can take this expression and substitute it into my first equation. All right, so what I'm going to say I'm going to do is I'm going to substitute the expression 4x minus 1/6 for y in EQ, just means equation number 1. All right, what does that look like? Now instead of y, we have 4x minus 1/6 is equal to negative 2x plus 4/3. This substitution step now has given us one equation with one variable x, and we can solve it. All right, let's go. We've got a little work to do. Variables on both sides. I'm going to undo the negative 2x here to get all my variables on this side. So I'm going to add 2x to both sides. That gives me 6x minus 1/6 is equal to 4/3. I'm going to add 1/6 to both sides. 6x is equal to, now I know I need a common denominator of 6, so I'm going to rewrite 4/3 with that common denominator. So 4/3 is the same as 8/6 plus 1/6. So 6x is equal to 9/6, which simplifies to 3/2. All right, we're almost there. Last step is I need to divide both sides by 6. If I divide this side by 6, you know, dividing by 6 is the same as multiplying by 1/6. So on the right side, I'm going to multiply by 1/6 since I have fractions. I'm going to be efficient and divide out my common factor of 3 and end up with x is equal to 1/4. Let's go back to our graph and see if that makes sense. Yeah, that x value very well could be 1/4. That feels like reasonable. All right, so I know my x value. Am I done? No, I need a value for both x and y. To remind myself, I'm going to write up here that I want to find my solution. And I'm going to write my solution just as a point, as an ordered pair. So I know I need an x value and I need a value for y. Now I've just found my x value, so let's go ahead and put that in. Now, how do I find my y value? Oh, you know what? I can input my y value into either equation. Because it's the point of intersection, inputting 1/4 into either equation is going to output the same thing. So I think I'm just going to use the second equation, mathematician's choice. You might want to try for yourself the first equation and see if we get the same thing. All right, so my second step is I'm going to find y, and I'm going to use equation 2, y is equal to 4x minus 1/6, and I know x is equal to 1/4. Let me substitute that in. Y is equal to 4 times 1/4 minus 1/6. 4/4 is just 1. And if I take a whole and subtract 1/6 from that whole, I'm left with 5/6. And there's my value for y. Let's go back and look at the graph. Does that seem reasonable? Absolutely. Okay, so it's a little bit less than 1. So here, graphing is a great strategy for solving systems. It's so visual. But unless you have a graphing tool that can tell you what that point of intersection is, you can't always read it accurately from the graph. So because of that, we have a couple of these algebraic techniques that we can use as well. Here's one called substitution. And we found that the point 1/4, 5/6, if we substitute 1/4 for x and 5/6 for y, both equations are true. We're going to do one more example, and then it's going to be time for you to practice. I'm going to scroll down to get some more space. Here's our new system. For this system, the first equation is negative 3x plus 5y is equal to 15. And the second equation is y plus 2 is equal to 3 times x minus 1. I'm just going to put these curly brackets as a system. Remind myself when I solve it, I want my solution to have both an x and y value. I'm just going to set this up so I'm all set. All right. Now, to solve substitution, we have to have isolated in one. This didn't catch up. Okay, let me reconnect. Try that again. Okay, I'm going to have to stop this video. We're just going to pick up where we left off on a second video. Oh, there we are. Okay, let's see if we can go from here. Sorry about that technical blip. All right. To do substitution, I either have to have y or x isolated in one of my equations because I need to know what y or x is equal to so I can substitute it in. Notice the system isn't set up like that. So I'm going to pick one equation, it doesn't matter which one, and one of the variables, it doesn't matter which one, and isolate it. Now my choice, I'm going to go to equation 2 and isolate y because it just looks like the easiest thing to do, all right? That's just why I chose that one, but any of them could have been possible. So my first step here is I'm going to isolate y in equation 2. I like to kind of write a few notes to myself as I go along because there's so many different steps, it helps to organize my work. So here's y plus 2 is equal to 3 times x minus 1. I'm going to subtract 2 from both sides to isolate it. So y is equal to 3 times x minus 1 minus 2. I might as well just simplify it so it's easier to work with. I'm going to distribute. Y is equal to 3x minus 3 minus 2 more, or y is equal to 3x minus 5. I'm going to record that up here just so that I know these are equivalent. It's equivalent to y is equal to 3x minus 5. Now the purpose, why I wanted to isolate one of the variables, is I can now take this little expression 3x minus 5 and substitute it for y in the other equation. All right, so that's going to be my next step. I'm going to substitute the expression 3x minus 5 into equation 1. So I'll have negative 3x plus 5. Now it's got to be 5 times the entire value that y is. So I'm going to wrap that in parentheses because I need to multiply the entire expression, 3x minus 5 times 5. And that equals 15. Here again, our goal, we took a system of 2 equations with 2 unknowns, And using the substitution, we now have one equation with one unknown that we can solve. Does it take a little work? Sure, but we can solve it. Let's go. Negative 3x, I'm going to distribute, plus 15x minus 25 is equal to 15. Combine my like terms, 12x minus 25 equals 15. Add 25 to both sides, 12x is equal to 40, and divide by 12. I can simplify this fraction. They have a common factor of 4, so x is equal to 10 thirds. Awesome, I found my x value. You know, they're not always going to be integers. Absolutely fine. I like the fact that I've written the solution because after all that work, I'm like, kick it back, I'm done. I'm not done. Got to find y. I can take either equation and substitute in that value for x. Why not take the simplified version of equation 2 I already have? I think that will just be the easiest way. So step 3, I'm going to find y. I'm going to use a simplified version of equation 2, and I know that the x is equal to 10 thirds. Let's go ahead and substitute that in. My 3's divide out, and I'm just left with y is equal to 10 minus 5. Y is equal to 5. If you want to double check yourself, you could always take the value for x and also substitute it into the other equation just to ensure that you have 5 as well, because you know that's going to be the point of intersection. Mathematicians, oh my goodness, I just turned my iPad off. Okay, there we go. I hope this video has helped you learn about this new technique called substitution that allows us to take a system of 2 equations and 2 unknowns and turn it into one equation with one unknown that we can solve from. What you're going to be doing now is some practice. So as you have questions when you get back from wherever you are, there's Math Lab on Monday. Please pop in, and it's a great time to ask questions. All right, see you soon.